Welcome to Your Soil, Your Data. I'm Drew Hemment and I'm project lead of the GROW Observatory. I've been working for 20 years on citizen science and digital platforms on a road that's brought me here to be with you today. Thank you for coming. Some of you are joining us today, having taken part in our pilot activities last year or the online course happening now, From Soil to Sky. For some of you, this will be your first encounter with the GROW Observatory. GROW is a citizens observatory, which is taking citizen science to the next level. Citizen science is not new. If you've taken part in the Great Bee Count, then you've done citizen science. GROW has a really big ambition to build a community of thousands of citizen scientists to address the urgent challenges of soil degradation and extreme climate events, to benefit the practice of individual growers, as well as to help answer some major challenges for science. You can be a part of GROW's two main citizen science missions happening this year. One on the changing climate, which takes place in one of 9 GROW places, and one on living soils and regenerative growing practices that you can take part in wherever you are. Plus, you can take part in discussions and activities on the GROW website and the 4 online courses happening over the year. But today, I'm delighted to introduce the GROW team who will be taking you through this webinar. So, firstly, Naomi. Naomi van der Velden is a plant ecologist. Her PhD was on forest community ecology. Her work focuses on plant communities, which has more recently been applying to food growing and edible plant communities. She now works as a senior researcher in agroecology at the Permaculture Association in Britain. Blair McKenzie is an agricultural scientist. His PhD was on soil science. He conducts research on soil management for improved plant production in grains, potatoes, horticulture and elsewhere, and environmental protection. As well as research, he has taught soils at all levels. Australian by birth, he has lived in the UK for more than 14 years and works at the James Hutton Institute in Dundee. Pavlos Georgiadis is an ethnobotanist, a biodiversity researcher, and an organic olive grower. His passion for growing and good food and its communities have seen him travel in several countries across the world, and he's now based in Greece. So today, we're going to be answering your questions. Later in the webinar, we have 20 minutes to hear and answer your questions, so please do send them in. You can ask questions directly in the comments section on this live broadcast, and also on the GROW Facebook page, or the GROW Twitter account, GROW Observatory, using the hashtag GROWWebinar. In the webinar, to begin, we'll discuss key issues to do with soils and growing that can help you in your growing and also that relate to global challenges. These are based on what you have said interested you during our online course. We will look at the importance of soil, soil properties and cultivation. We will also look at the combined data you have contributed during this course from many people and some of the insights that we can draw from that. Finally, we'll be looking at what's next in GROW. Just to remind you before we start, we'll answer all your questions. So please think about what you'd like to know and send them in at any time. We'll do our best to answer all that we can. So let's get started. Over to you, Naomi.
Thank you, Blair. Drew, and welcome to everybody joining us. Whether you've been doing the ongoing online course and contributed to the data that we're going to share and discuss here, or if you're simply interested in this topic and perhaps getting more involved in the work we're doing. Although the Citizens Observatory's projects, including GROW, are focused on Europe, we are pleased to welcome people from around the world who wish to contribute to citizen science and learn more from their own food growing and soils. The map that you can see now shows participants in our recent online course. In this course, we're exploring some of the key issues around soils, including their fundamental importance to human food production, ecosystem services, and biodiversity, as well as the threats that they're facing, like loss of organic matter and compaction. We took a hands-on approach and looked directly at our own growing spaces and soils, and we'll share here our combined results from the soil texture practical observations. We also explored some of our management practices and cultivation methods, and these sparked some interesting debates around the best approaches for sustainable practices, which we'd like to explore further today, particularly the issue around should we dig or till or not. The online course was also designed to help share the importance of citizen science projects like the GROW Observatory and to help us all take the first steps in working together over the next few years to develop real insights into soil and its role in food growing. We'll share a brief insight into some of the methods we use, again focusing on soil texture, and we'll also answer the questions on canopy cover that we set during the course. Let's start with Blair. Blair, what inspired you to become a soil scientist? Why is it that we need to better understand soils?
I think one of the things that I found growing up in a small country town in rural Australia, I was close to the River Murray, and it became very evident very early on that those areas which had access to water, I thought initially, where you could grow different things. So you could have dairy pastures or market gardens, but further inland it was barley. But then I started to realize it wasn't just the access to water, it was also the differences in soils. But the soils along the flats in the river had formed differently, had brought in material with lots of organic matter and different textures, and these were used for different things. So it was a combination of soil and climate that governed what we could grow where. And simply by walking out into the dairy fields or into the market gardens, you found differences in the amount of soil that stuck to your boots or your shoes. And it's that makes me realize that very early on, you can do some things and you can understand some simple things about soil. You can assess the soil physical conditions by simply digging into it and getting your hands dirty, looking at it, feeling it. And that's one of the important things about soil, is you can do some very important measurements and get a very good basic understanding without needing particularly fancy equipment. So we can think about assessing the physical condition of the soil simply by getting out and looking at them. And from that, we can then think about how we can manage those soils differently. Do we need to do different things if we're growing different crops, or if we're growing grass for cattle to eat, or if we're growing potatoes, or if we're growing a cereal crop, maize or corn. And we use soil, it's worth remembering, not only for food production, but also we use it to have buildings on, and we use it for many of our sports grounds, for our physical activity. We want a sports turf that we can run and play games on. So there's a whole range of different things, and the soils and the way we use soils are very different. Even within food production, there are big differences. A farmer growing rice in paddy will want very different conditions than somebody growing a rose bush. So we need to think about and assess those physical conditions. What we want roots of whatever crop we're growing to be able to proliferate through that soil. Plants will take up their water, their nutrients, and best when they have a prolific root system that can get out and explore the soil. And that also helps them have enough root length to be able to minimize the impact of any disease. So the limits to root production, which we start to think about when we start to think about texture, are things like, is the soil too hard? Does it prevent the roots penetrating? Does it have enough air? Can oxygen get in for the roots that need to breathe? Because the roots are just part of the plant, and they breathe like all plants and like humans do. They take in oxygen. So we can think about the hardness of the soil, the chemistry of the soil. Is it too alkaline or too acidic? Are there nutrient toxicities? And we can think about diseases. So there's a range of things we can think about and start to explore simply by understanding what the components of the soil are. And so how we think about those components, I'll hand back to Naomi.
Thanks, Blair. That's really interesting. So you mentioned there that one of the key ways of kind of measuring and assessing soil is to look at the soil texture. And that was one of the kind of hands-on fun parts of the online course, where we got out and dug up and touched and explored our own soil. And it's an easy place to start understanding more about your soil. So soil texture is looking at the mineral components of soil, and it's composed of the particle sizes that range from 2 millimeters and smaller. So sand is up to 2 millimeters, right down through silt to very fine clay grains. One of the ways we measured texture during the course was using a sediment jar test, where a sample of soil is added to a jar with some water, it's shaken over a few days to disperse those particles, and then they're allowed to settle. And the larger sand grains will settle out first, then the silt layers will form, and finally the smaller, finer clay particles will disperse out. What we can see now in this triangle is the range of soil textures from the course participants using this test. You can see the left-hand axis is showing the percent clay, and that goes from the bottom upwards. Down the right-hand side, from the top to bottom, is the percentage of silt, and along the bottom from right to left is the percentage of sand in that sample. And what you can see on that graph there is that a large number of our samples are falling down in the bottom corner, so they're quite sandy soils, a few spread across the loams, a few getting up into quite clayey soils that can be quite difficult to work with, and one or two more down into the bottom corner in the silty soils. So if you've got questions on any of this, don't forget to keep them coming in. What I would say about these soil textures is that it's that middle ground in the triangle that you can see, that where the balance between those three different particle soils is ideal, and these are our loam soils. So we know that soil texture is important, but what do these results actually mean? These different particle sizes allow different movement through the soil, so water and air to move through the soils. So where we've got larger particle sizes, there's also larger gaps between the soil particles, and that allows for faster and quicker flow of things like water between them. So sandy soils tend to be very well drained, and because that water moves through them, it also takes other elements with them. So clay soils, where they've got their finer particles closer together, better surface area cover of water, that also can hold nutrients within the soils. So they're more prone to being waterlogged, but they have higher nutrient concentrations. And of course, these things influence how well plants can grow. So plant roots, as Blair said, need to be able to penetrate down into the soil and not get too waterlogged. So getting that balance is good. Of course, it's not just texture that makes up the soil. So texture can tell us about building materials in the soil. So it will tell us, in an analogy of architecture, it will tell us that we've got cement and steel, but it's not how those materials are arranged. And that really comes down to something we call soil structure. So that's how the particles and the spaces between them are arranged. And this structure can often exist in clumps, where we see little aggregates or beds of soil. And these are the organizational units of soil. And it's the combination of this texture, the mineral components, and how they're grouped and clumped together that determines how well the soil functions for plant growth, so letting air in, allowing water to get to the roots, and so on. Now, as we can see, this soil physical condition or quality is impacted by by these components of texture and structure, and they can be affected by different things. So if you see a tractor on soils, for example, one of the things that heavy machinery does is compact the soil. And you might also feel this if you walk across your soil and you start to sink down into the soil a little bit. So we get that kind of compaction of soil that squishes these particles together, makes the spaces between them smaller. It's harder for water and air to penetrate into those soils. What you can see on the right-hand side of this picture now is a natural way in which soils can be compacted. And Blair told me that this photo is taken from soils in Croatia, where there's been heavy flooding and those soils are now waterlogged. And that water also helps to kind of settle and push the particles together, and also results in soil compaction. I'll move on to look at cultivation, which is the bit as a plant scientist I'm really interested in. So one of the reasons that we cultivate soil, that is, we dig or till it, is to loosen the soil, and we can make it easier for plant roots to proliferate into it. And this can be ploughing over with machinery, or digging with a spade, or just lifting the soil and loosening it a little with a garden fork. So there are various different reasons and means for doing cultivation or tilling of soil. That can be to improve the soil environment, or to make it more even, more homogeneous, so that all the plants that comprise your crop will grow in the same way at the same time, that have roughly the same access to water and nutrients. And that makes it easier to manage and harvest them together. So this is the reason when we prepare seed beds, for example, we'll often make sure our soil is very fine and loose, so that the seeds have good contact with the soil and they get a good environment, so they can germinate evenly, and you've got good chances of successful emergence. We might also cultivate for weed control. So it's common, I'm sure many of us find that we have to continuously weed, and we'll often be digging those weeds out to remove them and stop them interfering from the crop. So a weed is simply a plant that's growing in a place that you don't want it to be. An alternative to that kind of mechanical control of digging is to use herbicides that will take out the weeds. So this is kind of feedback. So Blair, can I pass over to you just to tell us a little bit more about why we might cultivate our soils?
I think there's a range of reasons that you've started to discuss about why we cultivate a soil. Some of it can be to improve drainage, to allow water to drain away. If we have waterlogged conditions, as much of Europe's had a lot of rain in the last few weeks, and the snow melts, we need to make sure that water doesn't run over the ground and cause erosion, but can run and penetrate into the soil. So we might loosen the soil to remove a crust or a hard cap, or those sorts of things. So we need to make sure that the water can get in. And of course, if the water can get in, we've got large pores that we create by digging, then we can get air into the soil. And as I've said, for most plants, certainly most of the plants we would be growing in Europe, they want oxygen, and they need oxygen to grow. And so we need to get air into the soil so that those normal biological functions can take place. Also, the other soil biology needs aeration. So the earthworms and most of the soil microorganisms need oxygen, and so they need air to get into the soil. So we can do that. We can also loosen the soil so that roots can proliferate and elongate and grow away from any diseases and things that may be there. So I think there are reasons to cultivate the soil, but it's not a one-size-fits-all, and it's not. I don't think we need to be dogmatic about it in any way. I think there are cases, there's arguments for and against. So I'll hand back to I think Naomi now.
Thank you very much. So we've heard from Blair there some of the reasons why we might want to till or cultivate or dig our soils. And we asked our course participants whether they do this practice, and you can see the results now on this graph. So what we see here is that many people practice actually reduced digging or reduced tilling, and some people practice no dig methods or would like to give them a go. So why would we not till? Well, even though tilling can help with weed control, so digging out the weeds and digging it over, not digging can also help with weed control, because you keep many of the weed seeds need light to germinate. So by not digging your soil, by not turning it over, you don't expose those seeds to light. And so over the time, they are no longer able to flourish. So we see the converse of this in the very famous World War battlefields, where poppies grew after the battles, because the soil had been disturbed and those seeds had been re-exposed to light. Not digging your soil can also maintain your soil structure, and that we were just talking about, and the porosity in the soil, making infiltration and drainage better. It can help to reduce erosion by keeping that soil and those soil aggregates together. And it can also, as Blair said, it can also help to maintain biological activity by not disturbing those soil ecosystems. So it's clear that there are pros and cons to both no-till and to digging. Blair, can you tell us more about this? Is it a question of size and scale of your land, or is there more to it than that?
Thanks, Naomi. I think there's more to it. And one of the joys about working with soil is that there's no fixed solution. And some of it will depend not only on the soil and how you're managing the soil, but the crop you're trying to grow. So that if you're trying to grow potatoes, you need to hill up around the tuber so that the new tubers have soil to expand into. Because if you don't have the soil around, then the light will get in and turn the tubers green, and you won't have a productive potato crop. So in my allotment, I have to hill up the potatoes to get the soil, and that means at some level cultivation. So I think we need to think about this. Certainly, we can take some extreme examples of paddies for growing rice, where the soil needs to be puddled so that the root systems of the rice plants can grow. So it's not a case just of managing the soil, but it's a case of getting the soil to fit the conditions that the plants want. And different plants need different things, not only potatoes, but carrots and parsnips need to be able to elongate evenly and easily, because if they hit anything, you'll get very deformed carrots, and that decreases the amount of use you can get from the land you've had. So there are a whole range of cases both ways, and for some things I try not to, and certainly if we've had in places where we've had good soil, good frost and very strong frost, that the soil may form a natural tilt and mean I don't need to till. So it depends on the season, it depends on how waterlogged the soil's been, the climate conditions, and the crop and the soil all come together. Thank you, Naomi.
Thank you. So one of the questions we've got is, how is the GROW Observatory going to help us to better understand some of these issues? And what we want to do is answer, in fact, key questions about how sustainable growing practices might affect the soil, and to find out if they really work in practice. Are they always effective? Does that vary by location? To be able to get answers to these questions through citizen science, we need to have a good method to follow, and this needs to be appropriate for the tools and resources that people have available. And it's important that we all follow the same method in what we do. Getting your method right is fundamental to scientific investigation. If a study is flawed or a bad study, it's the methods that are criticised. It's never getting wrong results. Might get unexpected results, but they're never wrong. So we need standardised methods that give us reliable results. There are many ways to determine soil texture, including laboratory-based tests, field tests, and we use two of these kind of field-based tests. A touch test, where the soil is manipulated through steps like forming a ball, rolling it out, forming a circle, which gives a good, quick estimate of texture. The second is a sediment jar test, where the heavier, larger sand particles settle out first, and we get those layers that we can then read off the relative proportions of each mineral component. If we have a look at this graph, we can see how our methods actually compared for our participants. So what we see is the same overall pattern that we saw in that soil texture triangle earlier, that more people have got sandy soils and sandy and loamy soils. It also shows the difference in the methods. The touch test, which you can see in orange there, doesn't include options for silty soils, and these are seen through the sediment test in green. I did a little bit of work comparing how well these two approaches turn out, and more than half the time people got exactly the same results or very similar results, 75% of the time. There's about 20-25% of this where we get a difference, and that's really because the touch test isn't differentiating out those silty soils. In terms of how confident people felt with the test, there was actually really little difference between them. People felt slightly more confident with the touch test, but really overall that wasn't a significant difference. So what we see here is a balance between a more quantitative, reliable test that gives a broader range of result options and being using a test that's somewhat easier and quicker to do. Or you might look at it as validating results from one practice by doing another, and then you can be more confident about the answer that you get. Finding out what works well is the key to the successful answering of the scientific questions in the GROW project. And it's an area that we're still looking into to find the best possible balance between scientifically valid results and methods that can be widely used. So that was an example with a quantitative test. What about more subjective assessments? So we look now at a question that we had in the course around estimating canopy cover, and a big thank you to everyone who had a guess at this photo. So what we're seeing here is a photo of an olive grove and then category classes in which we might guess the canopy cover underneath, going from very small, very little canopy, very open, right through to very dense, completely closed canopy where almost no light would ever be reaching the floor. So you can see on the right-hand side here the range of answers that participants gave. So mostly coming up around that 25 to 50%, a few a little over, a few a little under. Those of us that put this together, we think that this canopy falls in the 51 to 75% category, and that doesn't include the hills in the background, and it doesn't include that land in the foreground. So obviously where we put our boundaries can give very different results. What this really shows, however, is the value of doing things together. For measurements like this, it's great to decide on your own and then discuss with others. And this is an approach that I regularly use in the field when working with other scientists, and it works just as well for citizen science. So on that note, I'll pass back over to Drew.
Thank you, Naomi. So we're now going to have some of your questions. We've had some really interesting ones coming in, several of you during the webinar, and we also got some from a few of you during the online course as well. So thanks to Jose, Sarah, Diane, Caroline, John, Clara, David, and many more. We hope we'll get through all your questions. And also a thanks to the GROW team who are taking these questions in the background and passing them to us. And a reminder, please do send us more. You can add questions in the chat thread that you should be able to see in front of you now, or you can do so on our Facebook page or on Twitter using the hashtag GrowWebinar. So first of all, first question. Now we've got Pavlos, who will be presenting shortly, joining us as well. My first question I'm going to ask to Naomi and Blair, and it's a bit of an opener. So we've talked a lot about GROW and about collecting data. What are the benefits? What are the benefits for anyone on this webinar sharing their data to GROW? What's the point of this?
Thanks, Drew. Yeah, that's a really good question. So I guess there are two ways in which we want, in which we see a point to this data. And one is that as individuals, you can learn what works for you in your own garden. And by providing data, we're also helping you to understand that data that you're getting and what that means for you. And that this will be continuing beyond the scope of this course into our other courses and into the other activity that we're doing as well. So we're really focusing on not just citizens providing data to scientists to go and do stuff with, which is also fun, but really on helping people to understand what their data means and what they might do differently as a result. And then the second part is that kind of scientific analysis and use of the data. And you've heard there are two missions in GROW. One of these is really about climate change, and that's looking at using some of these soil and land measurements, including canopy cover and soil texture, as part of understanding satellite data from a ground truthing perspective. So you may know that satellites take images and they take surface observations, but they're unable to take observations below the surface. So part of the project is looking at matching up those satellite observations with below ground observations around particular sites. The other part is, the other mission, the Living Soils mission, is around testing out some of these regenerative practices. So we're hoping to set up an experiment looking into comparing polycultures and monocultures. And that will be about answering the question, do these things work at a small scale, which is one of the big under-researched areas. So we'll answer that broadly. And then we'll also, again, more specifically be helping you to understand what works best for you in your own garden and growing space. So if you've got a bit of growing space and you're looking for something to do over the summer learning, please join us.
Blair, do you want to add as well?
I thank you very much, Naomi. That's a great explanation. I think one of the things that continues to fascinate me about soils is that they are not discrete. By that I mean a plant, like the ones behind me, will either be a plant or it won't be a plant. There's no, your animals are either one species or another, but soils grade between it. So there's no, very seldom are there hard boundaries between one type of soil and the next type of soil. And it's this gradation that makes them, the management, interesting, because it can't be absolutely prescriptive. You can't say that's a gum tree, therefore I should treat it this way, and an olive tree you treat very differently, because the soils, there's a continuum between them. And it's that understanding what the continuum, what the change in texture is, how hard the boundaries are, where we see, even within relatively small areas, changes in things like texture, that we need data. And to get all those data points that we need is this thing that, you know, as a soil scientist, I can't map every bit of soil everywhere. So we need input to help us think about the distribution of the different textures across a landscape. Thanks, Drew.
Okay, thank you. I'm now going to turn to a question from Sarah Watts, who shared her question on YouTube. And I'm going to ask this back to Naomi. Have soil types been mapped in the UK or anywhere else? And on what sort of scale?
Thank you, Sarah. Yeah, that's a really good question. There are very good soil maps for the UK and for Europe as well, as there are, I know, in the United States, and I'm sure they exist for other countries. It often tends to be a national or regional project to do it. Scotland has got excellent soil maps, in fact, even better than the rest of the UK for some reason. And these maps can tell us different things. So some of them are very technical and tell us that it's a podzolic histosol from a particular region, and they tell us a lot about the parent material of the soil. So what rocks, what region those rocks, what kind of chronological, historical region, time period those rocks were formed in, whether Silurian or Ordovician or Devonian, and those kinds of things. And it tells us a little bit about how those rocks have weathered. So that can be useful if you understand what that means in growing terms. And the other thing I would say, that the scales of these maps are quite broad, in that if you look at where you are on a map, you're going to get an overview of what your parent material is like. But in my own garden, in one area, I've got good heavy clay soil, and then just a few meters away from that, I've got a really deep layer of sand, and that's because I'm on a floodplain, and it's built up at different times with different particles as flood events have occurred. Blair, you might have some more thoughts on this.
There are some wonderful maps available, freely available. So the International Soil Reference Database System has quite a lot of data available. And if you just go into one of the search engines and type in soil grids, that's SOIL GRIDS, you'll probably find things, or it might be soilgrids.org, and you can see a lot of information about what the soils are. But it comes down to soils being individual, made up of particles. You can map soils down at the millimeter scale, right up to the whole national scale. And different countries, for different reasons, have had different and different areas have had different access and different reasons to try and map soil data. Naomi's right that we've had some very good data here in Scotland, and part of the reason that we've been doing that is to go back and look at and compare changes, so we can work out what changes have occurred in the soil. So it's not only what the soils are now, but soils change in time as well as space. And we can think about, for example, has the amount of carbon in the soils changed? And thus, have the soils been contributing to greenhouse gas evolution, or have they actually become sinks and supporting more carbon, and thus taking carbon out of the atmosphere and helping to combat climate change? So there is a lot of soil information. publicly available, and obviously there's some that for people have done for personal reasons, but as much of that as we can as soil scientists and through the soil science organisations, we try and get out to as many people. There's lots of reasons to know and think about what soils are where, but there's a lot of information that's publicly available, and people are welcome to have a look at the online sites.
Thank you very much, Blair. So that last question was about the national scale, and we heard from Blair and also Naomi about how there were global issues there and also hyperlocal issues. I'd like to stay on that theme, and I'll bring in Pavlos this time. Pavlos you'll be hearing from a little bit more shortly in the webinar. And Pavlos, I'd like to look at the local level here, and if you could maybe answer, what are the key insights that an individual grower can take from the citizen science experiments that we've been introducing?
Yes, thank you, Drew, and thanks for this question. Well, I can share with you the experience I have in my olive grove on the northeastern coast of Greece, where we have been working with the soil. We like to say that we grow soil in which our olive trees can thrive in. But having engaged into the GROW mission, installing sensors and also doing the soil texture surveys and engaging on the content that participants on this online course learned, gave a really new perspective. It really allows the grower to focus deeper into the soil and try to build up a better understanding. Of course, you don't really need sensors and a scientific methodology as a farmer to be able to grow your crops. People have been doing this for ages. But now, in the context of new challenges, where we need to consider more things other than productivity, other than yields, things like being able to adapt in climate change, being able to reverse the trends of biodiversity degradation, understanding soil is of a very important question, very great importance. And what is GROW empowering users and participants to do in its missions is to try to generate their data, which can be put together with other pieces of data and insights from the growing side. And so those growers can start generating the new knowledge. When this new knowledge is shared in a wider scale, it can give insights for better watershed management, for creating Europe-wide or national-wide soil maps, which are giving an extra layer of information, not only in agriculture, but also in other aspects related to climate change adaptation, like predicting the extremity and occurrence of weather events, for example, or fire protection, or drought protection. That is very, very important for the farming system and the food security in Mediterranean countries like Greece. So by doing this in a mission style, this also gives the participants, growers, to be able to engage and understand the urgency of action.
Okay, thank you, Pavlos. Now shifting tack a little bit, a few people have asked us not about some of the measurements that we've been introducing, but about some of the challenges that you face in your growing space. And we had an interesting one from Caroline Osborne on Facebook. So, how should we best repair urban soils to allow them to support crop growing? And Caroline's particularly thinking of her own situation and also other places such as Detroit, where urban farming's flourishing. And one dimension of her question is she's interested in places where there's a decline, where previously industrial spaces maybe become open to regeneration and greening as well. Now, I think I'm going to ask that one to Blair.
Thanks, Drew, and thanks to Carolyn for the question. There are a number of issues around management of urban landscapes. The first thing is to recognise that, as the European Union does, that we are losing about an area equivalent to Berlin every year for soil that's being put under tarmac, either for buildings or roads. So we are losing soil in that way. But where within an urban environment, we can then look at what material we have. Often the soil that was there has been taken away. Maybe it's been sold, or maybe it's been used for construction. So it's a case of finding out what material is there, and then working in a social context. Think about how you can support that. And some of that comes down not to the straight physical sciences of soil science, but to coordinating and getting groups involved so that you can have combined growing areas. Because a lot of these things will require not just an individual person working alone. There are certainly things you can do if you can bring in soil from being made available from under new buildings, that you might be able to bring in and bring that material in to increase the depth of soil. So you've got a greater depth of soil for the plants, whatever plants you want to grow, be they for food or for amenity use, for gardens, for parks, for children to play in, and these sorts of things. There are some particular issues with urban soils, in that because there is a greater risk of contamination, either from deposits from cars and other vehicles and these sorts of things that can lead to soil pollution. And you need to be very careful that you try and find out first, before you grow any food in them, to make sure that the pollution, if there is no pollution there, or if there is pollution, then you can start to think about dealing with it. So I think there's a few starter points there to think about.
Thank you very much, Blair. We're running low on time for questions, but we've got loads more of interesting ones to get through. I'm going to turn to one from Diane Schofield on YouTube, who wants to share her experience of one of the experiments and ask our advice. Maybe Naomi, you could help on this one. So Diane asks, when I did the sediment test, the water remained cloudy. It didn't clear even after 6 days. What does this mean in terms of soil makeup?
Thanks, Diane. Yeah, that's a really good question. And I know that you're almost certainly not alone in experiencing that as well. There are different reasons why that might happen. One of them, and I'm sure Blair will be able to come in and clarify on this too, but one of them is that you might have organic matter in your soil that's kind of more sticky, or you might have very fine particles in your soil that are not settling out but are not necessarily a clay content. In the test, your jar, there were if you did the online course, you'll see there were images of 2 jars, and one of those cleared really nicely, and that's the one I've just used in the slides today, but the other one didn't clear completely, but your hand could still be seen through it. So even if you can still see your hand through it, that's probably settled out enough. Blair, do you want to come in on anything else that might be affecting it there?
Yeah, Diane, it's a good question. Having grown up in an area where I grew up, the rivers were never looked clear. The rivers always looked muddy, even though they were very slow flowing. And there are some reasons for this. First of all, if the clay is very, very fine, it will take much, much longer to settle. But even some clays are so fine, and if they are clays, because clay particles are negatively charged, they may not want together unless the space, the electrolyte, the water and solutes between them helps to make them come together. So one of the risks of erosion can be that the particles will separate. And that can be, the cloudiness can come from the mineral particles, or as Naomi's alluded to, can come from the organic matter in the soil. Very fine organic particles, down at that clay size scale, will also. And if you think about, for me as living in Scotland, the people that make whiskey talk about having different flavors in the whiskey depending on the different amounts of very fine organic matter that was in the water that the whiskey was made with. So it's possible that you won't see settling. The particles are so fine that they will behave and they'll stay apart and will take a very long time to settle. The one thing you could do, if you're very, very brave, is to swing the jar around and apply make a gravitational force, and that might force the particles to the bottom of the jar. But I'd say do it very, very carefully, because you don't want the jar flying off into the air and crashing and spreading broken glass everywhere. Thank you.
Thank you, Blair. And I'm very, very happy we managed to get whiskey into the conversation. Favourite subject of mine. I'm afraid we've run out of time for questions. We've had loads of really interesting ones we haven't got to. I'll take responsibility to that. So thanks to all of you for sending them in. Please do carry on the conversation afterwards on social media and also on the GROW forum. And on that note, we're now going to turn to the next section. We're going to leave Naomi and Blair behind, so thanks to both of them for their great presentations. And we're going to turn to Pavlos. So Pavlos, what's next in the GROW Observatory?
Well, lots of exciting activities are coming up in GROW. First of all, let me say that it has been wonderful to see our participants' interest in the online course and learn about their stories and practices. This is really encouraging as we are moving forward with some really exciting opportunities to engage, learn, and grow together. As a first step, we would like to invite you to register and join the second of our 4 free online courses this year. Starting on the 26th of March, it's called Citizen Science, Sensing the World, and looks at the science of Earth observation and how citizens can get involved in collecting data on their environment and on issues that matter to them. This will offer a great addition to the things you learned in our last course. You might also like to join our third online course, Living Soils, Growing Food, which starts on the 16th of April. This further investigates regenerative growing practices, including an experiment on polycultures that you can set up in your own growing space. So stay tuned with the GROW Observatory and the FutureLearn platform and the upcoming online courses. You're also very welcome to register in our GROW Online Community Forum at hub.growobservatory.org. That's hub.growobservatory.org. This forum is all about bringing the community together to exchange knowledge on soil and good growing practices through an open collaboration platform. Your contribution also gives us the opportunity to learn from you. We want to hear from you so we can design and deliver future themes and activities that suit you. We were so inspired to see participants join the online course from all corners of the world. For example, I was moved by a participant from Troms, a tiny island on the Norwegian Sea in the Arctic Cycle. And like last year, more participants from the Azores. These are tiny places. These are tiny pieces of land in the middle of the ocean. And it just shows that there is hope when people get a sense of how many we are, engage and participate even in the most unthinkable places. So this spring and summer, we would like to give you the chance to further engage with the citizen science components introduced in the online course. As we are about to launch our 2 missions, the Changing Climate mission, taking place in 9 GROW places across Europe, and the Living Soils mission, which is open to everyone, everywhere. So stay tuned. In the next months, you will be able to learn how to research and make sense of what happens in your own growing space and contribute to answering key wider questions on sustainable growing practices. We will give you full information on how to take part in the citizen science missions, and we will be here to help you if you have any questions. We want to help you in making observations in your own growing space and in using the results to understand if and how what you do makes a difference. Therefore, look out for our polyculture experiment coming up in the next weeks and months. And don't forget to follow and share our tweets, Facebook, and Instagram posts. Very importantly, keep in touch with what's going on in GROW. Subscribe to and share our newsletter and bring your local community into your journey with GROW. And remember, GROW is a citizens' observatory that belongs to all of us, the citizens. The more we engage, the more value we create for the land, for science, and for our own communities. Make GROW known to your local community. Practitioners, growers, local authorities, community gardeners, and whoever is interested in soil, food, and citizen science have a space in GROW. Here's once again some useful links for you to look out. The link to the GROW forum is hub.growobservatory.org, as well as Twitter, Facebook, and Instagram account. Link to Drew and what he has to say in conclusion of this very nice webinar.
Thank you, Pavlos. There was some inspiring words there. Really captured the ethos and the mission of GROW. Behind the GROW Observatory, there's a partnership of 18 organisations, ranging from the University of Dundee to the United Nations, FAO, organisations such as Hydrologic and Future Everything, the Met Office, and encompassing a range of science institutes, organisations that are specialists in digital media and empowerment through digital platforms, and also NGOs, organisations that themselves have been supporting thousands of growers and have been doing that in some cases for decades. It's a really powerful consortium, but the biggest part of the consortium is you. As Pavlos said, GROW is creating a community, and the community is at the heart of GROW. So we invite you to join us in this journey. Stay tuned, watch out on the GROW website and social media, and please take this energy, your questions, your discussion online through social media and the GROW forum, and we hope to see you on the online course that's happening now or in one of our 2 missions this year. Thank you very much and see you next time.